Alright guys, so we have been talking about some basic probabilities, conditional probability, joint probability, uh, the probability of the union of two events. But we've been doing a lot of this off of these two-way classification tables. Okay, so here's one of the examples off the study guide. So this is starting at number 27. Now there's a couple different study guides for test 2. I just decided to give a couple with different examples on there. But here's, questions that will be very similar to what's on your test. This is what we've been doing in class. So it says a pollster asked 1,000 adults whether Republicans or Democrats had better domestic economic policies. The following table gives the two-way classification of their opinions. Okay, now I have that. Oh, sorry, I dropped my pen. I have that hint there. And I've told you this in class, you always want to compute marginal probabilities first. And actually before that, you want to total out the columns first, because in order to get the marginal probabilities, you want to total out the columns so you know how many people are Republicans, how many are Democrats, how many are no opinion, how many are male, and how many are female. Okay? So what you want to do is total them out, and you want to total out vertically and horizontally. So every column and every row. Let's start with the columns first. Let's see how many total Republicans there are. So there's 150 and there are 240. So 150 plus 240, that's 390 in total. So 390. Okay. Oh, let me do something real fast. Let me fix this and change the size of my brush just a little bit. Okay, that should be better. All right, so there is 390 here. All right, so 390. All right, now let's see how many Democrats are there. There's 356 plus 184, and there's 540 in total. Then people of no opinion, 42 plus 28. So there's 70 of those guys. Oh, that's a little bit big. 70. Okay. Now, how many? Let's total up the rows. So, how many males are there? There's 240 in that first column. Then there's 356 in the second column. Then there's 28 in the third column. Looks like 624 in all. And then you have how many females are there? There's 150 plus 184 plus 42. There's 376 in total. Now, the way you know you've done this right, or maybe you've just gotten lucky with your mistake, is if you add this column, the total column vertically, you should get the total number of people, 1,000. And if you add this total row, you should get 1,000. So let's see, 390 plus 540 plus 70 gives me 1,000. So horizontally I get 1,000. Now let's see, 624 plus 376 is 1,000. So that's one way to double check yourself. If you add this total row and the total column and you don't get both times the total number of people, then you made a mistake somewhere, and that's going to make everything have wrong answers. So it's really important that you do that. Now, let's compute marginal probabilities. Now, remember, marginal probability is the probability of a single event without regard to other events. So like the probability of being male, or the probability of being female, or of being a Republican, or a Democrat, or no opinion, by themselves. So we could say that the probability, and we'll call it just M for male, is equal to, the probability of being male, there's 624 over 1,000. Okay, so what's that equal to in decimal form? Well, 624 divided by 1,000, move the decimal place 3 times, and you get 0.624. Now, let's look at the probability of being female. Well, the probability, let's just call that F for female. There's 376. over 1,000. So that is 376. Now let's look at the marginal probabilities of the Republican, Democrat, and no opinion. So there's 390 Republicans in this sample, so we can say the probability of R for Republican is 390 over 1,000. So that is 0.39. Let me fix that. Okay. We can say the probability of being a Democrat is 540 over 1,000, which equals 0.54. Again, these are the marginal probabilities. And then we'll say the probability of, let's say, NO for no opinion, that is only 70 out of 1,000, so equals 0.07. Now, those are the marginal probabilities. Again, those are the probabilities of one event at a time. Okay? Of males. Then of females, separately. Of no opinion. Of Democrat. Of Republican. All, again, all without regard to any other event. Okay? Single events. Okay? Now, I'm going to not write the questions here, so I'm going to go ahead and read the questions, and I'll use symbols. Okay, so I'm going to go along with how the study guide is labeled. Number 27 asks us for the probability that a randomly selected male out of this group of 1,000, the probability that a randomly selected person out of the 1,000 people in the sample is male. So we want the probability of male. Well, that's just a marginal probability. We already know that. We've already computed that. So you're working through a test. If you compute the marginal probabilities first, you'll probably already have some answers. So 0.624. Because again, it's just asking us for the probability that if we pull a random person out of this group, they'll be male. 624 out of 1,000. Okay. All right, number 28. 28 says the probability that a randomly selected adult says that Democrats have better domestic economic policies. So again, this is just asking us for a marginal probability. The probability of being a Democrat, of selecting somebody at random out of this group, and they're a Democrat. Well, the marginal probability is 0.54. Okay? That's number 27. Okay, now let's see here. Oh, nope, sorry, not 27, 28, rather. All right, number 29. Number 29 says the probability that a randomly selected adult is female given that she thinks the Republicans have better economic policies. Now, when you see that word given, you need to think conditional probability. So not marginal probability. All right, so let me say it again. The probability, we want to find the probability that a randomly selected adult is female given that she is Republican. So we want to find the probability of female given Republican. Okay? So remember how we do this. We look at our chart. Now we're assuming that this person that's randomly selected is guaranteed to be Republican. Once we know that that person's Republican, that person is on this this column right here, in the Republican column. So once a person is in that Republican column, what's the probability of them being that person being a female? Well, there's 150 females in that column. So 150, and there's 390 total in that column. Okay, so it's 150 out of 390. But, we want to express probabilities in decimals between 0 and 1 inclusive. So 150 divided by 390 is, okay, if the directions here, I didn't include on the directions how to round, or maybe I did at the start of the lesson, at the start of the study guide, but I'm going to round to 4 decimal places. So this is approximately 0.3846. Okay, actually, sorry, I'm looking here at the study guide. I rounded to 3 decimal places on the study guide. So I'll round that to 3 here. So 0.385 is if you round to 3 decimal places. So again, that was the conditional probability of a randomly selected person being female, assuming that they were also Republican already. Okay? So number 30. Number 30 says we want to find the probability that a randomly selected adult has no opinion given he is a male, or given he is a male. So we want to find the probability that in this group, a randomly selected person is no opinion, or has no opinion, given that the person is a male. Okay? So let's see here. If we're going to assume the person is a male, that means that person has to be on this column right here. No, sorry, I keep saying that. This row has to be on this row. So once we're guaranteed to be on this row, what's the probability of somebody, a male, having no opinion? Well, there's 28 out of 624. Let's see what that number is. 28 divided by 624. And I get, 0.045. 0.045. So a pretty low probability. Okay? Again, how conditional probabilities work is we're assuming that this happens for sure. We're assuming that male happens for sure. That means we're guaranteed to be on this column here. So, I said it again. Sorry, guys. This row here. So if you're in this row, once you're in this row, what's the probability of having no opinion? 28 out of the total number in the row, 624. That's number 30. All right, number 31 says, which of the following pairs of events are mutually exclusive? So I'll write these down, the abbreviations here. Okay. The question says, are female and Democrat, are those mutually exclusive? Now remember, mutually exclusive means the two events cannot be satisfied, cannot occur at the same time. So the way we're going to think about this is it possible, according to this chart here, for a person to be a female and a Democrat at the same time? Well, if you look at our chart, yeah, sure. There's 184 of them. So they are not mutually exclusive. Not mutually exclusive. Female and Democrat, the word would be, are mutually non-exclusive. Okay? What about, here, let me do this. I'll change over real fast, and I'll just X that out with a different color. So not mutually exclusive. Okay? Now let's see. The next option is female and male. Okay, according to our chart right here, is it possible for any of these 1,000 people to satisfy being female and male at the same time, according to the chart? Well, according to the chart, you either have to be in the male row or you have to be in the female row. So there's not any option to be in both rows at the same time. Therefore, these are mutually exclusive, because those events aren't satisfied at the same time. Okay? Let's look at C. Okay, C is female and Republican. Now looking at the chart, can you be female and Republican? Yeah, well sure. There's 150 of them right there. They're female and Republican. Therefore, those are not mutually exclusive, because they can happen at the same time. Let's see, let's do a couple more. What about Democrat and no opinion? Is it possible for somebody in this chart to be of no opinion and to be a Democrat? Well, not according to this chart. According to this chart, people are either classified as a Democrat or they're classified as having no opinion. There's not somebody in between that is both of those. Okay? So these would be mutually exclusive because they cannot be satisfied at the same time. And let's look at one more. There's several more, but let's if you follow the patterns here, you can figure out the rest. What about male and no opinion? Is it possible for the event male and the event no opinion to be satisfied at the same time? Well, yeah, we actually already found that probability right here. Well, a conditional probability that talked about these. So, yeah, there's 28 people that are male and no opinion. Okay? So those are not mutually exclusive because there are people that satisfy both of those events at the same time. Okay? Now, I'll just talk through the other ones. Let's see. The other ones were, Democrat and Republican. And I think those would be mutually exclusive because, at least according to this classification here, you're either Republican or Democrat. You're not anything in between. You're not both at the same time. You're either in one category or the other. Therefore, those are mutually exclusive events. All right, let's look at number 32. Okay, number 32 says, are the events Democrat and female independent or dependent? Are Democrat, female, independent? Okay, well, how do you check for independence? Now remember, there's a few different ways to check for independence. Here's one way. You can either see the probability. Now I'm going to use D and F here. Usually, in the formula, there's A's and B's, but here we have the event D for Democrat and F for female. Okay, so what we want to check is to see if the two events are independent. It's if this equality holds. The probability, of a Democrat given female, if that is equal to the probability of Democrat, that's one way to show that they're independent. Or we can see if this holds true. The probability of female given Democrat is equal to the probability of being female alone. Okay? Those are the two ways to check for independence. Now, it doesn't matter which one of these you use because the answer is going to be the same in both instances, either yes or no. If equality holds, then they're independent. If equality does not hold, they're not independent. Okay? Now, it's always useful to see, have we calculated any of this stuff already? Well, yeah, we've already calculated the probability of being Democrat. Actually, I'll just go ahead and do this. Yeah, I'll put a question mark there still. The probability of being Democrat is 0.54. So what's the probability of Democrat given a female? Okay, so if we're going to assume somebody's female, that means they're in this row right here. What's the probability of a person in that row being a Democrat? Well, it's 184 out of 376. So 184 out of 376. Now the question is, are these two things equal? Yeah, I don't know off the top of my head. Let's check. 184 divided by 376. And no. This right here is approximately 0.49. So those are not equal. So not independent. So therefore dependent. Okay, so those events are dependent. Now we can do this one right here too. Let's see, what's the probability of being female? Okay, that's a marginal probability right there. We already calculated that, 0.376. So let's put a question mark there still. Now what's the probability, this marginal probability? Now notice, these two things are not the same necessarily. It's possible, but they're not necessarily. So what's the probability of female given Democrat? So if you're a Democrat, you're in this column here. What's the probability of being female? 184 out of 540. And so the question is left-hand side equal to right-hand side? Well, I don't know. Let's check. 184 divided by 540. And no. This right here is approximately equal to 0.34. So these two are not equal. So we got the same conclusion either way. Notice if you get not equals here, you have to get not equals there, or we made a mistake somewhere. In either cases, the solution is they are dependent, not independent. Now, why does that matter? That matters if we start trying to calculate joint probabilities, because you have to calculate joint probabilities different when events are independent versus dependent. It's essentially just a little bit easier if you have independent events. But we have to remember that Democrat and female are not independent. Therefore, we have to calculate joint probabilities in a certain way. Okay? Now, that's number 32. Let's look at number 33. It says the probability that a randomly selected participant is male and favors Republican policy. So male and favors Republican policy. Let's see, let me scroll down a little bit. So this is number 33. We want the probability of male and Republican. Okay? The probability of male and Republican. Okay, now we need to remember what the formula for joint probabilities are. Okay, the formula for joint probability is, and we're using M's and R's here, is the probability of male times the probability of Republican given male. Now, why did I write it like this? I should have said this caveat a few seconds ago. This is because these two events are not independent. If these two events were known to be independent, okay, which they're not, if they were independent, you could just multiply the probability of being male times the probability of being Republican. But you have to check for independence, or here's the easy way, not easy way, but here's the safe way. The safe way is to always do it this way. Because if these events happen to be independent, then you'll get the same answer. But if you assume the events to be independent and then calculate just the probability, the product of the two marginal probabilities, you'll get the wrong answer. But here, if you calculate according to this method, assuming the events are dependent, and they turn out to be independent, you don't lose anything. You get the same answer, because the probability of Republican given male will be the probability of being Republican. And so you'll be fine. So what I'm saying is, if M and R were independent, then probability of Republican given male would equal to the probability by definition of Republican, and so you would be multiplying the probability of male times the probability of a Republican, and everything would be good to go. Okay? But you can't assume two events are independent without checking first. Now, I could tell you these two events are not going to be independent. We could check just like we did at number 32. So it's just to save some time to go ahead and do this. So what we have to do here is multiply the marginal probability of being male, which, I didn't mean to do that. The marginal probability of being male is 0.624 times the conditional probability of Republican given male. Now, have we calculated that already? Doesn't look like it. So the probability of Republican given male, so if you're guaranteed to be male, what's the probability of being Republican? 240 out of 624. So 240 out of 624. So what is 240 divided by 624? If we round to 3 decimal places, it's 0.385. So 0.624 times 0.385. So 0.385 times 0.624. And I get, for number 33, 0.240. If I round to 3 decimal places, that is. Okay? So the probability of being male and Republican, these aren't independent events, so we have to go the probability of male times the probability of Republican given male, do a little arithmetic, and get 0.24. All right? Number 34. Number 34 says the probability, we want to find the probability that a randomly selected participant is female, so probability is female, and holds the opinion that Democrats have better domestic policies. So F and Democrat. Now, again, this is a joint probability. The probability is female and Democrat. Now, just like here, if we do not know the events are independent, we have to use this method here to calculate joint probabilities. Now, we have already checked to see if F and D are independent. We found it, according to number 32, that Democrats and female, those two events, are not independent. They're dependent. They're dependent, so we have to use this method here, which says this is equal to the probability of female times the probability of Democrat given female. Okay, now we might have already calculated all these things already. Let's see. The probability of being female is 0.376. That's just a marginal probability. 0.376. Now, the probability of Democrat given female, we've already calculated that. It's right here. Democrat given female was 184 over 376. So let's see. 184 divided by 376. we found was, okay, if we round to 3 decimal places, okay, so we have 0.376 times 0.489. Okay, let's see what that equals. 0.489 times 0.376. That equals 0.184. So 0.184 is the joint probability of being female and a Democrat according to our data. That's number 34. Okay? Let's look at number 35. Number 35 says we want to find the probability that a randomly selected participant is male and has no opinion. So the probability of male and no opinion. Okay? Now, just like before, if you want to, we can check to see if these are independent versus dependent, or we can just go ahead and save ourselves the time and just calculate the probability of male times the probability of no opinion given male. Okay? Because whether they're dependent or independent, this will give us our answer. If they happen to be independent, we could have saved a few seconds of time by just multiplying the marginal probabilities. But if they happen to be dependent, like they are going to be, we would get the wrong answer. Now, look how I structured this. We've already calculated both of these things. That's a marginal probability. We've already calculated that. And look here. Probability of no given male. We've already calculated that. And do watch out for that on tests, because I frequently will structure questions to where you have already calculated something you need in a prior problem. Now, let's scroll up. What was the probability of being male? The marginal probability. 0.624. So 0.624, that's the probability of being male. The probability of the conditional probability of no opinion given male is 0.045. So all we have to do is remember how to find the joint probability, and then if we do that, we already have the two parts we need, and multiply. So 0.624 times 0.045, and I get 0.028 when rounded to 3 decimal places. Okay? So far, so good. Let's look at number 36. Let's see, next page, 36. The probability, we want to find the probability that a randomly selected participant is of no opinion and favors democratic policies. So the probability of no opinion and democratic. Now, let's say we're just chugging along here and not really thinking about this. Okay, here's how we would do it. The probability of no opinion times the probability of Democrat given no opinion. Okay, what's the probability of no opinion? All right, that's, let's see, that's a marginal probability. That's 0.07 right there, marginal probability. 0.07. Now, what's the probability of Democrat given no opinion? So this says, assuming that somebody is of no opinion, what's the probability that they're a Democrat? So assuming you're of no opinion, which means you're in this column, what's the probability that you're a Democrat? Well, it can't happen. If something can't happen, it has a probability of 0. So the probability of being a Democrat, once you're assumed to have no opinion, can't happen. So it's a probability of 0. So 0 times 0.07 is 0. Now, why should we have just automatically not even bothered ourselves with doing these calculations? Because right here, think about it. The probability of having no opinion and being a Democrat, those are two mutually exclusive events. That means they can't happen at the same time. Look right here. We said Democrat and no opinion are mutually exclusive. That means they can't happen at the same time. And the joint probability of two mutually exclusive events is always 0, because it's impossible for them to happen at the same time. So probability is 0. So we could have saved ourselves a few minutes there. But, you'll get the same answer even if you're not really paying attention. 37. The probability that a random selected participant has no opinion. Well, that's just a marginal probability. I kind of gave you a slow ball there. The probability that a randomly selected participant has no opinion. Well, that's just marginal. Let's scroll back up here. No opinion, 0.07. That's easy. All right, 38. The probability that a randomly selected participant is female, so probability is female, or that she thinks Democrats have better economic policies. So it's Democrats, it's F or D. Now, thus far, we've had and. Okay? This is an or. Now, remember, what's the method there? The probability, it's called the union of these two events, is the sum of the marginal probabilities, so the probability of female plus the probability of Democrat, which we know those two things already. Those are marginal probabilities. But you have to subtract off the joint probability. So the probability of female and Democrat. All right, notice here, we have done these answers already. That's a marginal probability. We got that the first 3 minutes of the video. That's a marginal probability. Female, Democrat, those are both marginal. Now look, we already did this. The probability of female and Democrat is right here, is 0.184. So we have the three pieces to this particular puzzle. It's just a matter of finding them and putting them together. So that's why you need to do your work nicely and neatly so you can go back and find those answers. Okay, so let's see. Let's scroll back up here. The probability of a female, marginal probability, 0.376. So 0.376. The probability of being a Democrat is 0.54. Right here. Marginal probability. And the probability of being female and Democrat is right here. 0.184. So minus 0.184. So let's see. 0.376 plus 0.54 minus 0.184, and I get 0.732. Okay? Again, you can't just add the probabilities, because what happens is if you add this marginal probability of female and the marginal probability of Democrat, what you end up doing is double counting the people that happen to be female and Democrat at the same time. So what you're doing is subtracting off one of those times you double count, so you single count. That's what's happening there. Okay? Let's see. Let's get a little more space here. Number 39. Number 39 says the probability that the randomly selected participant has no opinion or is male. So again, here's a union probability. The probability of no opinion or male. Okay, so it's the union. Again, that's an or. Make sure to really pay attention to where it says and versus or. Because remember, we have two different methods to calculate probabilities. So here, the method is probability of no opinion plus the probability of male minus the probability of no and male. Now check back. Have we done all these things? I think so. The probability of no opinion, that's marginal. Probability of male, that's marginal. Now this joint probability right here, we have already done that. The probability of no and male is, I thought we had done it. No and Democrat, oh no, we haven't done it. So, it's fine. We'll do it on the fly. So no and Democrat, no. Oh no, right here, no and male. Yeah, we're good. Oh, now that brings up a question: is the probability of male and no the same thing as the probability of no and male? Let's check. Okay, I'll do this in a different color. Let's see. Let's see. What color do I want? Let's see F3. Here we are. Let's see. What I want to see is look at the probability of no opinion and male. Okay, so that would be the probability of no opinion times the probability of male given no opinion. Okay, so what's the probability of no opinion? Okay, let's go back up here. No opinion is 0.07. What's the probability of male given no opinion? Okay, male given no opinion, is that anywhere? Male, I don't see it. So male given no opinion. So assuming they have no opinion, what's the probability of being male? Well, it's 28 out of 70. So once we assume somebody have no opinion, we're in this column here, and what's the probability of them being male? 28 out of 70. So 28 out of 70. Now what does that equal? 0.07 times 20. Oh, what did I say? 28 out of 70? Yes, 28 out of 70. And look what we get. 0.028. Notice here, 0.028, 0.028. So, turns out that the probability of no and male is equal to the probability of male and no opinion. Okay? So that's a property to think about. If you swap these, it doesn't change the answer. Okay, at least for what we're doing here. Now, I don't want to say that's true always, but for what we're doing here, that'll be fine. Okay, so going down here, I know that the probability, well, I've already gotten both of them now. The probability of no and male, and the probability of male and no, those are the same thing, are both 0.028. Now, let me change back to the green for us. And we can say, okay, probability of, going back to the original problem here, of probability of no, that's just a marginal probability. The probability of no opinion is 0.07. The probability of male, I believe, was 624? Yes, 624. Minus the probability of no and male, which we said was 0.028. Let's see, 0.07 plus 0.624 minus 0.028, and I get, 0.666. Hopefully you're not superstitious. That's funny. All right, let's see here, number 40. Number 40 says, the probability that the randomly selected participant is of no opinion or favors democratic policy. So the probability of no opinion or democratic policy. Now, you remember when I didn't even mention this a few moments ago, we were calculating, here's the formula for a union of probabilities, where you add the two marginal probabilities and then subtract off the intersection, the joint probability. Well, remember that if the two events happen to be mutually exclusive, you don't have to worry about this part right here. Because if the two events are mutually exclusive, that's going to be 0. Well, if you think about this right here, no opinion and Democrat are mutually exclusive, which we already showed to be true right here. That is, the joint probability was 0. So really here, all you have to do is worry about adding the two marginal probabilities. No opinion and the marginal probability of Democrat. Now, technically, we are still subtracting off the probability of no opinion and Democrat, but that just happens to be 0. Okay? So what's the marginal probability of no opinion? 0.07. Plus the marginal probability of being a Democrat. Oh, let's go back up here. That was 0.54. Minus the probability of the joint probability of no opinion and Democrat. Well, you can't be in both of those categories at the same time, so the joint probability is 0 because they are mutually exclusive events. So let's see here. That's 0.54 plus 0.07, and you get 0.61. Now let's look at the last one. Number 41. It says, what is the probability that a randomly selected participant... Okay, so the probability that a randomly selected participant is male... Now, pay attention to the wording here. Male or doesn't think that Democrats have the best economic policies. So it's male or not Democrat. Well, we haven't done one like that before. I did this on purpose. It makes you think a little bit. So what does this actually mean? Male or not Democrat? Okay, so I guess it means, so if you're male and doesn't think the Democrats have good policies, that means your probability of male or Republican or no opinion. Now that looks weird. We haven't done that before. Now the hint I give you, if this weirds you out, is to use the idea of the complement. Now let's go back up to our 2A classification table. So we're looking for the people that are male or Republican or no opinion. So we're looking for people that are male. We're looking for these guys. Sorry, I did the wrong one there. We're looking for people that are male. So these guys, or these guys. No opinion or Republican. Okay? Now here's the quick way to do this. I say, remember the idea of the complement. So if this is what we're looking for, the probability of all of these circled groups of people, well, let's not worry about fretting over how to do it when we have three groups down here. Let's instead say that is the complement, the probability of being a female Democrat, the only group that's not circled there. It's the probability of being a female Democrat Okay. Oh, I messed that up. Oh, let's see here. I said the right thing. What I want to do, but I wrote the wrong thing. So I want to find the complement of what I'm looking for. Now, the complement of what I'm looking for is just this group right here, the 184. But remember, the probability of a set, so the probability of A plus the probability of A complement has to equal 1. Okay, so here I can say, and again, this is one hard one you have to think about. We can say that this probability that I'm looking for is 1 minus the probability of what I'm not looking for. So the probability I'm not looking for is the probability of female and Democrat, which is, we've already done that, I think. Female and Democrat is 0.184. Okay, so 1 minus 0.184 is 0.816. And there we go. That way, because here, we don't know how to deal with that. Because we could, and you can do it. It's just, we haven't covered it, and it gets a little complicated when you have 3 sets here. So, since we haven't learned how to do it like an analogous way to number 39 and 40 and 38, the way to solve it is using the complement. To go up here and say, if we're looking for the probability of being Republican, no opinion, or male, well, I circled everything we're looking for. The probability of all of those people that are circled, what that leaves out are only female Democrats. So if I figure out the probability of being a female Democrat and subtract that from 1, the theorem we had about the A plus A complement has to equal 1. That guarantees us that we can find our solution by just subtracting 0.184 from 1, and there we go. So that was a challenging problem, but I wanted to put that on there just to get you to open up a little bit and remember the idea of complement. Now, this fact right here, we will use that, especially chapters 5, as you've seen, chapter 4, chapters 6, chapters 7, 9, 8. We're going to use that a lot. So don't forget this idea of what it means to be a complement. Again, just to review, A is some event or maybe series of events, and a complement is everything else in our sample space that's not in A. Okay? So here we said, here's all the events, male, Republican, or no. I guess I could say this specifically. We could say the probability of male or Republican or no plus the probability of male or Republican or no complement. Those two things have to equal 1. Well, probability of male or Republican or no, that's what we're looking for. Plus, we have to recognize this right here is the probability of being female and Democrat. But we know this, and we can find that easily. So the probability of male or Republican or no opinion plus, okay, we found that to be 0.184 equals 1. And now we can just solve this equation and get this answer right here. The probability of male or Republican or no opinion equals 1 minus 0.184. And there you go. Cool. All right, so that was, let's see, questions like, I don't know, it was questions 27 through 41. I hope it's been helpful. If you have any questions, feel free to ask. Again, just review this as you're studying for your test, test 2, or if you're just somebody out in YouTube watching, hope it's been helpful as well. Again, we were answering questions about a two-way classification chart on a sample of 1,000 adults who happen to be either Republican, Democrat, or no opinion, male or female. Hope it's been helpful. Talk to you soon. Have a good night.